Hello, this is Professor Kuehn, and this is Introduction to Astronomy. In my last lecture, I began discussing Aristotle's book De Caelo, or On the Heavens. Let's review what we talked about last time. In the previous lecture, we were interested in the question of what are the heavens made of? And the argument that Aristotle makes is that the heavens, that is, everything outside of the region of the earth, the heavens, is made of a fifth element called ether. How did he arrive at that? Well, what he did is kind of use common sense. He said that here on Earth, when we look around us, it seems like there's a wide variety of kind of objects. There are people and dogs, there are cats and there are squirrels, there are rocks and there are trees, but everything really can be made up of four simple substances. Those four simple substances are earth, air, fire, and water. That was sort of the four elements of the ancient periodic table. And some things are made up, some of simple substances or simple elements, and other things like people and rocks, some rocks and trees are compound substances. That is, they're made of perhaps 2 parts earth, 1 part fire, maybe 1 part air. And the idea is that if we look at these kind of simple elements, they seem to have certain natural motions associated with them. So when we drop a rock, it falls straight down. When we light a fire, it seems to rise straight up. So what Aristotle did is he said that there are certain kinds of motions that are natural to the simple elements. Those simple motions are straight line motions, either straight toward the earth or straight away from the earth. If you think about the center of the universe being the center of the earth, then straight away from the earth would be the natural motion of things like air and fire, and straight toward the center of the earth would be the natural motion of things like earth and water. But now he says, look at the heavens, the skies. We look at the moon, we look at the stars, we look at the planets and the sun, and they are going around the earth. They seem to have a circular motion going around the earth. And he said, not only are they undergoing these circular motions, but as long as anyone has cared to observe them, they've been doing the exact same thing. Therefore, this kind of motion that the heavens are exhibiting must be a natural motion to them. They must not be an unnatural or violent motion. That is a motion that violates their nature, because if it was a violent or unnatural motion, it would have soon passed away and stopped. So there must be some reason why they're going in a circle like that. They must be a substance that has a natural motion in a circle. Well, we already know with the four elements that are here on Earth, the earthly elements, earth, air, fire, and water, their natural motion is not in a circle. Their natural motion is straight line motion. So there must be a fifth element out of which the heavens are made. That's the argument that Aristotle gave in his first book. We went up to about chapter 4, so it's worthwhile taking a minute to review that. Now what we're going to do in this lecture is talk about his next set of arguments. We're going to jump ahead to his chapter 2 of On the Heavens, book 4. So we're skipping over a number of things. So let's spend a minute talking about what we are skipping over. So in the end of book 1 and the beginning of book 2, what Aristotle is going to argue is, first of all, that the body of the universe, if you think about the universe or the world as a whole as an object, that is a finite-sized object. It's not infinite in size. And at the end of book 1, he presents some arguments for why he thinks that the universe is finite in size as opposed to infinite. Furthermore, he argues that there is but one universe. Now, this might sound obvious to you, but it's actually interesting because he considers the possibility of there being more than one universe, more than one world, he would say. But he says, no, that's not the case. Interestingly, this is something that modern cosmologists and physicists consider the possibility. You might have heard of multiverses. They use this as a reason to perhaps explain the unique characteristics of our own. If you say, well, there's really nothing that unique about our universe. If there are thousands or millions of universes, all with different characteristics, it's really no surprise that we live in one where there happens to be life. So that's one of the rationales that scientists today sometimes use for asserting the possibility of multiverses. Aristotle considered the same question. Are there more than one universe? And he says, no, there is but one. Now, we're not going through a proof of that. I'm just kind of ticking off this kind of conclusions that Aristotle arrives at. Another point that he makes that we skipped over is that our universe, he claims, is eternal. That is, it had no beginning and it will have no end. And he presents some arguments for why he thinks this is the case. It's interesting because later on, when we get to Johannes Kepler, who was a scientist, a philosopher, mathematician, physicist, astronomer in the 1600s, he is going to talk about Aristotle's book on the heavens. He's read it very carefully, and he's going to agree with some things that Aristotle says and disagree with others. In particular, he's going to take issue with Aristotle's assertion that the universe is eternal. Specifically, he says that it contradicts sacred scripture. He's a Lutheran, and he believes that the creation account in scripture is correct. And so he says, while we may agree with Aristotle on some things, we as Christians are going to disagree with him on the eternity of the universe. In any case, it's an interesting point because over time, people argue about whether or not the universe has a beginning. Aristotle says, no, it had no beginning and it will have no end. Okay, and maybe I'll say one other thing about what Aristotle argued in this section that we skipped over. He talks about if the universe is moving in this sort of circular motion. Let me draw a little picture here, just to remind you of the worldview that he's defending. He is going to argue that the Earth is at the center of the universe. So I'll draw the Earth. I'll draw a little plus sign or a cross on it. That's a symbol that's often used for the Earth. He says, well, the Earth, you've got the moon going around the Earth. I'll draw this just sort of schematically at this point. There's an orbit of the moon going around the Earth. And then you have these concentric circles. It's a little bit more complicated. His theory is a little bit more complicated than what I'm drawing here, but you get the main point. And you've got, this is the symbol for Mercury. It kind of looks like the symbol for a woman, but it's got little horns. That's Mercury. And then Venus, which is a symbol for female, like this. I'm not going to draw the circles, I'll just draw parts of them. You've got the sun. By the way, there's debate about whether or not Mercury and Venus are below the sun, that is closer to the Earth, or above the sun. Different people had different opinions at this time. So we've got Mercury and Venus and the sun. Then you've got Mars, the symbol for male. I guess that's the symbol also for Volvo automobiles. And then you've got Jupiter right here. That's kind of the symbol, looks like a 4 kind of. And then you've got Saturn. It kind of looks like an H with a bar through it. That's Saturn. So these concentric circles, this is the basic geocentric worldview that Aristotle and others are going to defend. And finally, on the outside of that, you've got the sphere on which the stars are located. So if you, I'm just going to draw a little bit more of this one. If you think about this huge sphere like this is sometimes called the celestial sphere, or the sphere of fixed stars. That is the sphere on which these stars are located. So Orion, the Big Dipper, Leo, Virgo, all those stars have certain configurations. They're sort of pasted or glued to the sphere. That's the worldview that he's going to have. And the Earth is sitting still, and this whole thing is kind of rotating around. The North Star would be up here. That would be Polaris up here. We'll come back to the planets and the sun and so on in a little bit, but we're just focusing on this sphere. He's going to say this is a spherical object, this body right here. It actually is an object, and it's rotating around the Earth. Okay? Now, why does this thing rotate around the Earth? He's going to say that the source of the movement of the celestial sphere is outside of it, sort of out here in this region. There is something that is causing this sphere to rotate around. So it's outside of the body of the celestial sphere. So it's a little bit strange. I mean, we think of space as being a vacuum nowadays. He talks about it as if it's a body. It's an object on which these stars are located, rotating around. And what is this thing that causes this sphere to rotate around? Well, the important thing to note is he says there must be a cause. Okay? There must be a cause of its movement. There must be a cause of the movement of this sphere. Okay? Because he says, and what is that cause? He says it is the prime mover. The prime mover. And this is something that later on people will start saying, well, this is God, or can be identified with God, this prime mover, the cause of motion of the entire universe. Okay? And it's important to note that he says the prime mover is something that itself does not need a cause. Why is that? He says nothing that is in motion can move without a cause. Okay? And since this celestial sphere is in motion, it cannot move without a cause, and so that cause must be something outside of it, and that cause, he says, is the prime mover. Now, immediately you might ask the question, wait a minute, but doesn't the prime mover need a cause? Well, no, not according to Aristotle's theory, because you have to be very careful about how he articulates this. He says anything that is in motion must have a cause, or anything that changes must have a cause. Since the celestial sphere is in motion, therefore it must have a cause. But the prime mover itself, he will argue, is not in motion, or it is not changing, therefore it does not need a cause. Okay? So that's an important point that he makes. And by the way, this exact argument is later going to be picked up by none other than Thomas Aquinas. So Thomas Aquinas, very famous Catholic thinker and apologist, used Aristotle's argument for the prime mover. He kind of baptized this. He kind of used this for to argue for the existence of God. If someone did not believe in God, well, then this kind of reasoning would lead one to the existence or the belief in the existence of a God. It doesn't necessarily get you to the God of Abraham, Isaac, and Jacob, but it does get you to the existence of a God. This, by the way, is the argument from motion. The argument from motion, that is, anything in motion or anything moved must be moved by something. And then the ultimate mover of everything itself is an unmoved mover, and that is what Aquinas identifies with God. This is Aquinas's first way, is sometimes what it's called. He has 5 arguments for the existence of God, and he basically uses the Aristotelian argument here as his first way or first proof, logical, rational proof for the existence of God. We're getting a little bit ahead of ourselves. We're diverging a little bit from Aristotle, but I think it's really interesting to note that there are some theological implications to the kind of approach that Aristotle is taking that are very influential and significant for later Christian thinkers. Okay, tell you what, why don't we pause there for a moment, and then we will jump right away into chapter 4. This is kind of all by way of background, some of the stuff that we skipped over at the end of book 1. So next time we're going to go into Aristotle's book 2, his chapter 4, and in that chapter he is going to ask, what is the shape of the heavens? So next is book 2, chapter 4 of On the Heavens. And this, of course, is in A Student's Guide, chapter 2. And in that, the question that we're going to be addressing is, what is the shape of the heavens, or the celestial sphere? What is the shape of the heavens? And again, by heavens, we mean everything kind of out here. This is all the heavens. What is the shape of that? In particular, what is the shape of this body that makes up this, what we said here is a celestial sphere, but he's going to argue, in fact, that it is a sphere. Okay, so let's stop there, and we'll pick this up next time.